Today, on Guess What I Found Out, there is a place in the Indian Ocean where gravity is broken. Not broken like a malfunctioning appliance, broken like a 3 million square kilometre dent in the fabric of Earth itself, where the ocean surface sits a full 300 feet lower than it should, ships weigh 50 tons less than expected, and GPS satellites have to fudge their math just to keep up. Scientists have known about this thing for 75 years, and only just figured out what caused it. Welcome to the gravity hole, also known around here as the big missing chunk. Let us start with what gravity actually does to the ocean, because this is one of those cases where the explanation sounds weirder than the mystery. Most people picture the ocean as a flat surface that curves gently with the planet. It is not. The ocean surface is constantly being tugged toward dense concentrations of mass underneath it. Mountains underwater, thick slabs of crust, dense mineral deposits, all of these pull water toward them and create subtle bulges. Conversely, areas with less mass, thinner crust, lighter rock, create zones where the water effectively sags. The technical term for the shape of the ocean surface, as defined by gravity, is the geoid, and it is lumpy in ways that would make a cartographer cry. In the Indian Ocean, south of the tip of India, there is a geoid low, a sag, a bowl, an area where the ocean surface sits roughly 92 meters, about 300 feet, below the global average. If you could drain all the water away and look at the seafloor from space, this region would appear as a massive, smooth depression. It covers an area larger than the entire subcontinent of India. And for most of the time since its discovery, nobody had a convincing explanation for why it existed. The discovery itself is a wonderful piece of scientific history. In 1948, a Dutch geophysicist named Felix Andries Venning Mynes sailed through the Indian Ocean measuring gravity using a golden pendulum. A golden pendulum swinging on a ship, detecting missing mass under the ocean. Science used to have so much more style. His instruments showed that gravity in this region was measurably weaker than it should be, suggesting that a significant chunk of Earth's expected mass simply was not there. He published his findings. Scientists scratched their heads, and there the mystery mostly sat for the next 7 decades. Now, to be clear, weak gravity in this context does not mean you would float away if you stood here. The difference is subtle. A ship crossing this zone weighs roughly 50 tons less than it would elsewhere, which sounds dramatic until you realize these ships weigh tens of thousands of tons to begin with. The effect is real and measurable, but not something you would feel in your knees. What you would notice if you had extremely sensitive instruments is that the ocean here is lower. The water has been pulled away by gravity elsewhere, leaving this bowl behind. That description, by the way, is not a metaphor. Gravity literally pulls water. The oceans are not just sitting in a basin. They are being sculpted in real time by the varying density of the rock beneath them. The big missing chunk is the most dramatic example of this effect anywhere on Earth. Here is where it gets genuinely strange, and where we need to talk about a dead ocean. About 140 million years ago, there was an ocean called the Tethys Sea. It sat between the ancient landmasses that would eventually become Africa, Europe and Asia, and it was enormous. Then the Indian subcontinent, which had broken off from what is now Antarctica and Africa, began moving north. Over tens of millions of years, at the blistering pace of a few centimeters per year, India ploughed into Asia. When it hit, the Tethys Sea was destroyed. Its oceanic crust, dense and cold and heavy, was shoved downward into the mantle, a process called subduction. The Tethys essentially got eaten by the collision. Scientists had known this for a long time. What they did not know was what those sunken slabs of ancient ocean floor were doing to the mantle around them. In 2023, researchers at the Indian Institute of Science ran simulations on supercomputers, modelling the behaviour of Earth's interior going back 140 million years. What they found was that as those Tethys slabs sank, they disturbed something called the African Large Low Shear Velocity Province. That is the official name. It is a massive, anomalous blob of material deep in the mantle beneath Africa, and it has been sitting there for hundreds of millions of years. Scientists sometimes call it the African superplume, which is both more dramatic and, honestly, a bit easier to say. The sinking Tethys slabs disrupted the edges of this superplume and triggered the formation of low-density magma plumes, lighter than the surrounding mantle material, which rose up into the region beneath the Indian Ocean. Lighter rock beneath the surface means less mass. Less mass means weaker gravity. Weaker gravity means the ocean sags. The big missing chunk is, at its core, a ghost. The ghost of an ocean that died when India ran into Asia. If that is not enough to make you stop and stare at the ceiling for a while, here is the part that keeps the researchers up at night. The gravity hole is not static. The plumes beneath it are still moving. They are shifting, and current measurements suggest they may be growing. As these underground structures evolve, they influence ocean circulation, which influences heat distribution, which in turn influences weather systems across the Indian Ocean basin. The monsoons that billions of people in South Asia depend on for agriculture are, at least in part, shaped by the ocean temperature and current patterns in this region, which are, at least in part, shaped by a gravity anomaly, which is caused by the ghost of an ocean that was destroyed 140 million years ago. That chain of causation is so long and so strange that it sounds like something you would find scrawled on the wall of a conspiracy theorist's office. Except, well, it is the current best scientific understanding, published in peer-reviewed journals, generated by supercomputer simulations and confirmed by satellite measurements. If your brain is doing something uncomfortable right now, good. Drop a like on this video. That little button is how you tell the algorithm that genuinely fascinating things are worth finding, and it helps us keep making these. There is also a broader implication here that the researchers are careful to point out. The Earth does not forget. Events that happened 140 million years ago are still echoing through the planet's interior, shaping the ocean surface, influencing climate, affecting the orbits of satellites, and puzzling scientists with pendulums on ships. The idea that geology is something that happened in the distant past and is now mostly finished is wrong. The planet is a living system where ancient events have very long tails. The 2023 simulations also raised a question that nobody has fully answered yet. If the Indian Ocean has a gravity hole this dramatic, caused by geological events we can now trace and explain, what else is out there that we have not explained yet? The researchers noted that the plumes beneath the Indian Ocean are not the only anomalous structures in the mantle. There are others in different regions with different histories. Some of them may be generating their own geoid anomalies that we have not yet characterized or understood. The ocean covers 70% of Earth's surface. Our detailed knowledge of what is happening in the mantle beneath it is still incomplete. The Indian Ocean gravity hole was sitting in plain sight for 75 years before anyone cracked the explanation. It is a reasonable question to ask what else is hiding in the data we already have. And here is your question for this week. Curious George. The gravity hole is actively influencing monsoon patterns and ocean currents right now. If the underground plumes that cause it continue to grow and shift, the effects on regional climate could intensify. Does that concern you more or less than climate changes driven by surface-level human activity? Leave your answer in the comments and walk us through your thinking. There are no wrong answers, just interesting ones. Subscribe to Guess What I Found Out, because this is what we do. We find the things that were hiding in plain sight, the mysteries that turned out to be weirder and more connected than anyone expected, and we bring them to you. Every week. Do not miss it.